So this is my screencast assignment for conceptual objective number 2, quiz number 2. The assigned question was number 60 on page 52, and the problem says, coasting due west on your bicycle at 8.4 meters per second, you encounter a sandy patch of road 7.2 meters across. When you leave the sandy patch, your speed has been reduced by 2 meters per second to 6.4 meters per second. So I do the picture of it here. You start off at 8.4 meters per second going into the patch. Then you exit the patch with a velocity of 6.4 meters per second because you were reduced by that 2 meters per second. And then the sandy patch in the middle was a total of 7.2 meters across. So part A says, assuming the sand causes a constant acceleration, what was the bike's acceleration in the sandy patch? Give both magnitude and direction. So it's asking for the bike's acceleration in the sandy patch. So we know we're looking for A, and then I stated my givens, which we know we have our change in velocity because it gives you the initial, which was the 8.4, and then the final, which was the 6.4, and then you're given the distance you're traveling over the sandy patch, which was 7.2 meters, and then it tells you have a constant acceleration. I chose this equation from our list from the chapter because you're given everything in this equation besides A, which is what you're looking for. So for velocity final, I plugged in 6.4 meters per second. For velocity initial, I plugged in 8.4 meters per second. For change in distance, or change in x, the final distance was the 7.2 meters, and then you subtract 0, which was your starting point. So then you just multiply the 7.2 times 2, and then 8.4 squared, you subtract that on the other side. And then dividing by the 14.4, you get an acceleration of negative 2.05 repeating meters per second squared. And rounding that, you get an acceleration of 2.06 meters per second squared, and it's negative because acceleration is equal to the change in velocity over the change in distance, and in the change in time. So as time moves on, you're entering this sandy patch and it's slowing you down. So the acceleration is just being negative means that your velocity is getting smaller for every second squared that you're traveling. So it just means you're slowing down. And then part B says, how long did it take to cross the sandy patch? So you're looking for time, and then you basically have all the givens that you had before, except for now you actually know the acceleration. So choosing from the problems that actually have the variable of time in it, I chose the equation velocity final equals velocity initial plus AT, and plugging in velocity final to be that 6.4, and then the velocity initial again to be that 8.4. Then you just found acceleration, which was the negative 2.06. So that you plug that in for A, and then you're solving for T. So solving for T, you get this big number, and then rounding, you get the time is equal to 0.97 seconds overall, which was the time you spent to cross the sandy patch. And then lastly, part C. So you know velocity initial, it says suppose you enter the sandy patch with a speed of only 4.5 meters per second, so they're changing the initial velocity. Is your final speed in this case 3.4 meters per second, more than 3.4 meters per second, or less than 3.4 meters per second? And then explain. So it's changing your initial velocity, and it wants you to consider what the final velocity would be. So doing the same exact thing as the first, like the part A, I use the same formula because now you still have that acceleration from the original, but they're just changing one of the variables from the beginning. So I chose the equation velocity final squared equals velocity initial squared plus 2a, change in x or change in distance. They're trying to get you to figure out velocity final so you don't know that, and then velocity initial was the 5.4, and you're going to square that. Then you use the same acceleration that you found in part A as the negative 2.06, and then you multiply that by the 7.2 meters that you crossed the sandy patch. So solving for this right hand side, you actually get a negative number, and since you have to square root velocity final to get your answer, and you can't square root a negative number or negative decimal, it actually means that this ends up being not possible. So you actually are stopped in the sand. So for the final answer, you get velocity final to be less than 3.4 meters per second because your final velocity is actually 0 meters per second squared, since you end up being stopped because you don't go into the sand patch with enough initial velocity to get you to a velocity to get you out of the sandy patch. So you end up being stopped in the middle of it.